Hello everyone, I'm Dr. Ajay. Today in this tutorial session we are going to solve a two-layer and one-layer theory, which is Boussinesq and Burmister's method. Let's directly go to the problem statement. Our problem has three different steps, three different scenarios. In our first scenario, a plate bearing test was conducted on a subgrade soil. For which, plate bearing test was conducted on a subgrade soil, and the plate, it was rigid plate with 12-inch diameter, and the total load required to cause the settling of 0.2 inch plus 10,600 pounds. So the applied load is 10,600 pounds. Allowable deflection is 0.2 inch. This is our first case. In our second case, after a 10-inch of gravel base is placed on the subgrade, again the plate bearing test is conducted, for which the load is 21,600 pounds for the same deflection. For this, yes, this is the second scenario. Third scenario is actually, for the second scenario they had already given the thickness of the base material, which is 10 inch. But we don't know the material properties of subgrade, and we don't know the material properties of the base. Third scenario is the same, but we have the subgrade, we use the same base material, and in this 50,000 pounds tire is placed with the contact pressure of 100 psi over the circular area. Okay. First, what is the tire pressure? Tire pressure is 100 psi. Load is 50,000 pounds. And the deflection, we have to maintain the same level of deflection, which is 0.2 inch. What is the question? We have to determine the thickness of the space layer. Okay. For this subgrade, we will say our first step is to find the material properties of the subgrade. This one we call it as E2. This is our first step. In the second step, we have to find E1. For this, E2 will be taken from step 1. Once you know E1 and E2, you can determine the thickness required. Okay, let's solve the problem. So, yes, our first scenario was subgrade with a rigid plate. We know this is a single layer, so it's a Boussinesq equations. We know the deflection allowed, load, we just need the material properties. We all know the equation for the Boussinesq one, which is deflection is pi times 1 minus mu square QA divided by 2 E2. So here W0 is the deflection, pi 1 minus mu square. Mu is already assumed, which is 0.5. Then Q is Q, you know the load, you know the area, you know the diameter. From this you can calculate the Q. How do you calculate Q? Load by area. Area is pi by 4 T square. A is again the diameter, which is 12 inch divided by 2 E2. In this, you already know W0, pi you know, mu2 mu you know, Q is P by D square, you already know, A you know. The only unknown is E2. From this, you can get the E2, which is 3310 psi. Okay, that's all for the case 1. In case 2, now we have 2 layers. 2 layers, we need to use the Burmister's theory, or we can use the Burmister's charts. Again, for the deflection, we know W0 is 1.178 QA by E2 times F2. What are all the parameters we know? We know the deflection, you know the Q. Q is again, we can get it by load by area, which is load is already known, and area is also already known. It's the same plate, rigid plate, so it's 12 inch diameter. A is again already known, just 12 inch. E2, you know. Now you need to find F2. Once you find this F2, you have to refer back to the chart. There is a chart which is the function of E1 by E2, which is function of H1 divided by A times F. So in this, you already know H1, which is the thickness, 10 inch. A, you already know 12 inch diameter. F, you already obtained it from this equation. Once you plug in, you can find the E1. E2 is already known. So you have to use the design chart for finding the E1. If you do this, you will get the answer E1 as 13,200 psi. Okay. The last one, the third scenario. Now, again, it's a 2-layer system. Base E1, subgrade E2, which is already known. E1, E2, you already know. Now we need to find the thickness H1. How do you do this? Now difference is it's the same equation, but instead of a rigid plate, it's a flexible tire. So the coefficient alone will change from 1.178 to 1.5. So from this, yes, deflection is already known. Q is again, what is this? Q is already known, which is load by area. A is already known. How do you find A? You know the pressure, this is Q, already known. Now you need to find the area. Area is contact area. So you know the load, you know the stress, contact stress. If you get this, load is here, stress is here, if you divide it, you will get the contact area. From the contact area, assume it as a circular contact patch, and you can get the diameter, which is again around 12.6 inch. Okay? Yes. From this, you already have 2, you will find F2. Once you have the F2, use the same design chart, which says E1 by E2 plus function of H1 by A times F. What do you know already? E1, E2, A you know, F you know. Now we need to find H1. Just look back at the chart, you will find the H1. So if you do this, the answer H1 is